going to start the program tonight. My name is Joel Kirshen. I'm president of the St. Louis chapter of CSI. I'd like to welcome everybody tonight, both those here in person and those online. I think we have a really good presentation for you tonight. Before we get started, I wanted to run through a couple of announcements here. First of all, I want to recognize Suprema for bringing some good food tonight for those who were able to join us in person. Suprema is, everything building products, or building enclosure products. So reach out and talk to Kevin about that. After that, let me introduce George Everding, who will lead us into the presentation tonight.
Thanks, Joel, and welcome everyone. This year's program theme has been learning from failure. And in November, we set the stage looking at failure, different types of failure, who's responsible for failure, and most importantly, what can we learn from failure? So this month, we're going to be looking at fire, and specifically passive fire protection. Now, when a layperson comes into a building, a person who doesn't know much about construction, and you ask them, do you feel safe in this building? Do you feel that this building is fire safe? And they'll look around, they'll see the sprinklers, or they may see the fire extinguisher cabinets. They may look on the back wall over here and see a fire alarm. These are all active fire protection systems. They all need to be maintained. A good building owner will do a good job of maintaining them.
Passive fire protection systems are things that we as builders and contractors and building owners know, but are not readily obvious. The walls, the doors that are propped open. The doors that are propped open. Thank you, Steve. Go back and close those. Spray on fireproofing. Penetration Firestopping. These are the passive systems. Let's go back to grade school. We all kind of learn this, right? It takes three things to start a fire: heat, fuel, and oxygen. We all kind of learn this. The fire triangle is really, really famous. In balanced fire protection, we have the same sort of thing. We have detection, or alarms. We have suppression, or sprinklers. These are active systems. Detection, or alarms, is the building saying, hey, I smell smoke. Let's get the heck out, right? The suppression is the sprinklers going off or the extinguishers being used. Underlying all this is passive fire protection systems. These are the things that are not seen but are every bit as important. And it takes all three to adequately protect the building against fire. There's three main areas that passive fire protection systems address. One, you want to protect the structure. We'll be talking in length about spray-applied fireproofing, but there are also intumescent fireproofing systems. Generally, the spray-applied is not seen. The intumescent can be a finished coating. And then, obviously, there are enclosures to the structure. Masonry, or the Masonry Institute. That's a really good thing to use. Different word class are not used so much anymore. Compartmentalization, firewalls, fire barriers, and so forth, smoke barriers, and so forth. And then opening protectors. And that's your fire doors, glazing dampers, and so forth. And then we'll be talking about the penetration and joint fire stopping. Since we're talking about the first and the last of those three, I thought I'd spend just a moment talking about compartmentalization. This is probably, I don't know, maybe a school or a large church. But you can see the yellow lines there probably represent a 1 hour rated wall, and the red probably represent a 2 hour rated wall. The concept here is that you're isolating portions of the building so that people who are not in the fire affected area can get out in extreme safely, and so the fire is contained. Like I said, this has been going on for a long time. This is actually a drawing that was done under the 1997 building code. So compartmentalization is a big deal, and also testing. Has anyone other than me witnessed this test, had an opportunity to see the test? It's wonderful, isn't it? It is just like so cool. It is the E119 test, and the interesting thing about it is that the standard Cairo temperature curve and the test has been largely unchanged since 1917. So for more than 100 years, you are able to compare assemblies, doors, walls, and so forth. So that's basically the middle part, and that's all we're going to talk about that. We are going to talk at length. Our speakers are about spray applied fireproofing and penetration and joint fire stopping. We're pleased to have with us our first speaker by Zoom, Bill McHugh. We first met Bill when he was involved with the penetration and joint fire stopping people, so he has experience there. He's currently the executive director of the Firestop Contractors International Association, and also has some expertise in the fireproofing world. So as soon as we have him ready, we're going to go.
He should be able to go ahead.
Bill, welcome. You can start now, I guess.
So good evening, everyone. Thanks, George, for the introduction. My name is Bill McHugh, the Executive Director of both the Firestop Contractors International Association and then also the National Fireproofing Contractors Association. Really glad to have the opportunity to spend some time talking about both, not in detail. I'll leave that to the guys from Hilti and GCP Applied Technologies. But what I'll do is give you an overview of some of the key things in the industry. First things first, really appreciate being at another CSI chapter. CSI, I joined 40 years ago, and yeah, I was like 10 when I joined, maybe 5, and then was a charter member of the Northern Illinois chapter, president of the Northern Illinois chapter, region president, North Central region, and then served on the Institute Board of Directors as well. So CSI is in my heart, and I'm with you guys, even though I'm not face-to-face with you. A couple of things, the Fireproofing Contractors Association has an accreditation program, some standards that are available for you for free to help you with specifications at www.nfca-online.org. And we do a lot of stuff as far as industry advocacy work, working with the American Institute of Steel Construction. Next week, I get to hang out in Rochester, New York for the International Code Council's structural building chapter hearings. In other words, chapter 15, 16, and the admin chapter gets heard at Rochester, New York. And then also other places in Canada that we hang out to. To all the specifiers in the room, working for design firms or working as an independent practice, we'll give you a free handbook of fireproofing knowledge. If you want it, just email info@nfca-online.org and we'll get it for you. So what we're here to talk about today is fire resistance rated building elements and assemblies. Really appreciate you setting things up, George, with the compartmentation pieces, fire walls, fire rated assemblies, including fire barriers, fire partitions, smoke barriers, and smoke partitions. The final two are the horizontal assembly and then also the exterior wall. It's really important to communicate through construction documents those code-defined terms, and I'm really glad that you used the terms right out of the code. A couple of things about fire resistance. George mentioned ASTM E119 UL 263, evaluating the ability of the materials and methods of construction to resist long-term impact of fire. And really, there's two things in fire resistance. George pointed out compartmentation, containing the floor, containing the fire to the room or floor of origin. And then the second piece, which is maintaining structural integrity of the building. And all of this is found in the International Building Codes, Chapter 7, fire and smoke protection features. One of the key things to remember, though, is none of these fire resistance pieces or elements, if you will, becomes fire resistance rated unless it's been through a fire test. George mentioned ASTM E119, UL 263, E119 being over 100 years old. All the other fire tests are based on that large-scale fire test E119 UL263. You'll find all of this in chapter 3, 4, 5, 6, 10 for the required ratings. You know, how long should the fire resistance rating be? Go to chapter 4 for high rise and other types of occupancies, 6 for table 601, and of course, chapter 3 for other issues as well. But chapter 7 is how the ratings determined. You'll probably hear more details from John Dalton and others about that. But really, we're trying to maintain structural integrity. I'm going to go really fast through this because I'm sure John Dalton and the guys from Hilti have some slides as well. Key thing I want to point out in fireproofing is when you're evaluating any of the entrants to the marketplace, and there's a lot of new people entering the market because of the intumescent fire-resistant materials. Looks like paint, it looks like it's easy, but you know, fire resistance just isn't easy. One of the things that we found at our office is that companies call in and say, hey, Bill, I've tested my fireproofing on the bottom of a roof assembly or a beam assembly. And, you know, we did small scale tests and all that kind of thing. And I've spent a bunch of money and we think we're ready to go. And then I usually say back to them, have you done full scale testing with a load applied? Well, what do I mean about that? That means, you know, like George said, let's get exciting and go to UL's Northbrook, Illinois facility, or you've got one right there in St. Louis. You know, one day Carboline might want to take you to their laboratory and do a tour of their horizontal assembly, fire test assembly, which is almost as big as the one here at UL. Lay out the beams, lay down the decking, get the reinforcing steel together, pour the concrete, and then let it cure. We don't let it cure for 28 days. This goes for several months because all that water of convenience has to be gone, and then it has to get to a certain equilibrium. Otherwise, when they fire test it, the assembly will try to move the moisture out of it way too quick, and it'll basically explode in the fire test assembly, which is no fun. So here's the horizontal assembly that you'd see at UL or any other fire test facility that has a horizontal assembly furnace to fire test these things. Look at the size of this. Small scale testing would not let the assembly sag enough to really test whether in fire conditions that the fireproofing will stay in place and pass that fire test after a period of time. All the gas furnace concept is done, as you can see here. Our buddy Andy that's in the fire test facility. I mean, this is just to show you how big these things are, 12 foot by 18 foot. An old picture, notice the 70s kind of hairdo over on the right-hand side, but you know, all joking aside, the load is applied, whether it's through rams or filling up buckets with water, big ones, as you can see. But the idea is fire test it with a load applied to it. Why? Because that's what happens in real buildings, file cabinets, office furniture, God knows what else people are going to put in these facilities. But you want to fire test it so that horizontal assembly sags and puts strain on the fireproofing that's on the bottom of it. The manufacturers that you have in the room have tested their products in these types of applications. E119 says the acceptance criteria needs full scale with a load applied, not partial, not small scale, not modified or anything like that. So be careful when people start calling on you to talk about fireproofing, because many of them will have not invested as some of the manufacturers have. George put up the time temperature curve. You'll probably see it again, but this same time temperature curve is used for fireproofing, fire stopping, fire rated doors, dampers, glazing. The whole fire protection package uses the same time temperature curve. It just changes when you change the type of materials that are being tested to become systems, because all of these are systems that are listed in some kind of a directory. We'll talk about that in a couple of minutes. But the acceptance criteria for floor ceilings, roof ceiling assemblies, full scale testing, load supported, no flame passage, 250 degree Fahrenheit rise over ambient, meaning 325 degrees for the wall and for the floor as well. But when it comes to the structural elements, then you've got a different acceptance criteria. I'll let John Dalton from GCP handle that as well. So rapid fire through fireproofing. Now let's talk about fire stopping a bit. Fire stopping is part of the compartmentation package that George mentioned. Structural fire resistance, structural steel, and even sometimes concrete assemblies when the fire rating is only 2 hours and need to go to 3 hours. Maybe spray fire resistant materials are used on the bottom of a horizontal assembly or on a beam of some kind or a column to increase the fire resistance rating of that concrete assembly. But when it comes to compartmentation, as George pointed out, certainly the fire resistance rated wall and floor is tested to ASTME 119, but then you've got all of these other holes that are made for various reasons in a building, to run piping and services, to run air, to allow people to egress the building, and even to see things, because fire rated glazing, a new concept that's really taken off over the last few years. Really what we need to do, regardless whether it's fireproofing or fire stopping, it's got to be specified right, it's got to be designed right, it's got to be installed in accordance with the listing and the manufacturer's installation instructions. Why? Because we were the code proponent, the FCIA, the NFCA, to drop that into the International Building Code, Chapter 7, that these products are installed in accordance with the manufacturer's instructions and the tested and listed systems. And then there's special inspection concept. You know, some states adopt it, others opt out of it, but in your specifications to cover yourself, make sure you've got it covered in Division 1, of course, the schedule of special inspections, and then some kind of a qualification or, you know, the standards that are used for fireproofing and fire stopping will be over in the other spec in chapter Division 7. For fire stopping, it's 078400. For fireproofing, it'd be 078100, the general specifications for fire stopping and fireproofing. When it comes to installation, UL qualified contractors, FM 4991 contractors, and then also there's UL qualified contractors for SFRM fireproofing. And then we've got from the NFCA a contractor accreditation program as well. The inspection standards, E2174-2393 are the fire stop inspection standards. The FCIA was a code proponent to put those into the International Building Code back in the 09 cycle for the 12 code. And special inspection for fireproofing has been in going back to the legacy codes, whether it's BOCA, UBC, or the Southern Building Code Congress International. The one thing I want to really point out to you, though, is that it's not a product sport, any of this stuff, whether it's GCP or Hilti or Carboline or 3M, STI, Isolitech, any of the members of the NFCA, the FCIA, they've all spent millions of dollars at FM approvals or at Intertech or any of the other laboratories coming up with tested and listed systems. And visiting the product IQ, this is how people compete. You got to show the system. Can't just show the product or look for the product, but the system is what the contractor needs to be selecting. And by you communicating that through the construction documents, it'll get done right in the field. Part of your specification, whether it's fireproofing or fire stopping, there's a listing under the UL product IQ that'll cover, you know, whatever it is, boards and wraps, SFRM products, IFRM products, all found here at Product IQ. Intertech has their directory too, just go hang out here. Or if you want to go to the FM approval guide, mainly fire stopping, not much in the steel fire protection industry in that as well. But wanted to really want to hone in on is specs, you know, it's the Construction Specifications Institute. So let's talk just for a couple of minutes about specs. You know, the fire stopping, the general spec, you know, there's 5 or 6 different sections when going to master format 2020 version that talk about fire stopping. But really you want to put it all in one place because the standards are very similar and the installation pieces are the same. The special inspection, similar. Keep it all in one place, 078400, and then specify in the other sections where the penetrations might be, plumbing, piping, et cetera, to go look at 078400. Same thing with fireproofing. You know, start with that 078100 and then use the standards from there as well. Key things to remember, it's a system specification talking about fire resistance and not a product specification, but you still need to cover product properties in your specification to make sure that products are able to be to survive in the environment that they're going to be exposed in. FCIA member in good standing, NFCA member in good standing, all good things. There's an FM 4991 standard for the approval of Firestop contractors, a UL qualified Firestop contractor program. Again, the NFCA accredited fireproofing contractor for either SFRM and IFRM. And of course, we think it's really important to make sure to involve the manufacturer in the education of these contractor companies and their personnel as well. When it comes to inspection, same thing, ASTM E 736 E605 for fireproofing SFRM. And then in the fire stopping arena, it's the ASTM E21742393. But they all need to have two approvals in the International Building Code Chapter 17. The agency gets approved by the code official, and then also the special inspectors get approved. They have to prove competency. No certifications are required. Prove competency through passing an exam of some kind. Even the ICC has an exam, the International Code Council as well. These are the standards that would be used for inspection. Make sure you put them in your specs because they're mandated by Chapter 17 of the International Building Code as well. One thing for the life cycle of the building, you heard George talk about maintaining protection in the buildings, in fire stopping and fireproofing, both of them. In order to maintain them well, they have to have an inventory of fire resistance. That term inventory is new in the 2018 version of the International Fire Code, not the building code, but the fire code. The building owner manager has to annually visually inspect fire resistance items that are visible. In other words, if you can pop a ceiling tile, look above the ceiling and go see whether there's fireproofing and fire stopping, and if the wall is actually still in place, is done annually, and it's mandated by the fire code. Most of the building owner clients that you have would probably not know that, because as George said, people look up and say, okay, I got to maintain that sprinkler system. I'll pay somebody to come in and do that. Got to maintain the alarm system. Good, we'll bring somebody in. But when somebody says you have to maintain the fire resistance, that passive fire protection package, usually you get a clueless look from the building owner and manager because it's not in their culture to do that. You can communicate that to get it started by using 017839 project record documents. How do we know that? I reached out to our friend Dennis Hall, who was the guy at the master format task team in 2000 to change from the 5-digit master format to the 6-digit master format. Say, Dennis, where do we put this? He said, this is where you put it, 017839. So what you want to do is in Division 1, reference back to the specs in 078400 and 078100 so that you get the manufacturer's installation instructions, the listings, and the life safety drawings communicated to the building owner manager so they have an inventory of stuff, fire protection stuff, fire resistant stuff, so that they can maintain it for the life cycle of the building. So George, I hope I haven't used up my time. Just wanted to very quickly go through some of the basics on the fire resistance and then let the details get taken care of by our experts at GCP and Hilti.
Bill, I hope you can hang on. We're going to try to do questions and answers at the end of this. I'm sure there'll be quite a few, and we're going to hope to have everybody there for that. There were a lot of people, as you can tell, who put this together. My sort of driving force was, how do we maintain this? And obviously, it's important that we design it correctly, that we build it correctly. Our next two speakers are going to be talking about that, but I wanted to make sure each of them would talk about maintenance, because as a building professional, I think many of us are guilty of this. We do a passive fire protection system, and we sort of throw our hands up and say, well, we're done, right? This is going to work behind the scenes for us for the rest of the building. And we're finding out, I hope in this series of talks, that isn't true. I'm going to introduce our next speaker, and pardon me, John, I'm going to call it Grace. It's GCP now. Grace for many years was for us to go to for fireproofing. John Dalton, some of you may recall him from 2012, I think it was. John was in town to talk to us about fireproofing and the changes in codes. And we were looking at the tragedy, the failure that happened at the World Trade Center.
And thank you very much to Bill McHugh and to George for the opportunity. Good to see you both. Looking forward to seeing you both in person, and we might get back to that Scottish Arms pub, George. Anyway, so my name is John Dalton. I'm the technical manager for fire protection at Grace. Is probably just the easiest way to put it. GCP Applied Technologies is our current name. I've been with GCP for about 20 something years, and I've been the chairman of the ASTM 621 committee for about 15, and sit on various committees and have done some work, I think, with the NFCA over the years. So and when I spoke with George, I only came into this pretty late in the day. My colleague Trish Coleman was supposed to be doing it, so I spoke with George yesterday. We're going to talk about, I think, I'm going to talk about failures in fireproofing, what we can learn from them, what we have learned from them as part of the fireproofing industry over the past 20 odd years or so, or even longer, maybe going back to the early 1990s, stuff that has happened in fire protection and what we've learned from it, and what failures have been, and if they indeed have been failures. You know, first off the bat, we would think about the two big fires that we've had in the United States in terms of structural fire resistance over the past 20 years. Clearly, the two World Trade Center towers and Tower Number 7, and you could look at those and say they were significant failures of the fire resistance systems, and in some instances they were. You would look at the two Twin Towers and you'd say, well, they did fall down. Certainly they did, and there's very few buildings in the world would be able to survive that sort of an impact, but they did stay upright for the best part of an hour, and thousands of people, maybe tens of thousands of people, were able to escape the buildings before they came down, based upon the fire resistance systems that had been put in there. Clearly the sprinkler system would have been overwhelmed almost immediately, and it was a huge fire in terms of heat, not really enormous, but a huge fire that burned at sort of 1,000 degrees or so for the best part of an hour, and the buildings came down, as we all know. World Trade Center Tower Number 7 collapsed later on that day, and nobody was killed. It was an empty building at the time, but it was a spectacular success. So the World Trade Center Towers 1 and 2, a failure maybe, but a lot of people got out based upon the fire resistance systems that were there. Tower 7 lasted for 5 hours in a fully engulfed flame over several stories. And there was a lot of information gained from that because it was so widely studied, because we had so much information that was available to us. And so in terms of, is a failure? Maybe, depends on what you define as a failure, but we learned a lot from it. So what did we learn from the steel failures at the World Trade Center and other large fires? We learned that restrained construction is less conservative. Restrained construction is a manner of doing the fire test that allows the supporting frame to help support the beam. And it's a much less conservative approach than the unrestrained systems, which are all temperature based. And big fires where the buildings have collapsed or there was a complete failure of the system tended to be restrained. Long span joists are not tested, and perhaps there's too much reliance on the manufacturers. So the manufacturers will test to a certain system in most cases we would hope a full scale furnace at underwriters, but we don't have the ability to test everything, and we weren't able to test, and we're still not able to test long span joists, except if we would go to somewhere like NIST that have the capacity. But most of the commercial construction is done at UL or Intertech, and that they don't have the capacity to test non-standard conditions. And that's what I say, too much reliance on the manufacturers. So a condition which nobody had tested, nobody could test, and we were still sort of able to engineer our way to a system that eventually didn't turn out to be successful. The long-term bond of SFRM, so SFRM is a term we use to define passive fire protection. That long-term bond of the steel, or of the product to the steel, is vitally important. And certain fireproofing types, not products as such, but certain fireproofing types have shown that they have bond issues in the long term, right? So one of the things we learned from the World Trade Center Tower was that there was a significant portion of the steel had no fireproofing on it at all, because it had been in place for the best part of 30 years, best part of 30 years, and the bond of the fireproofing to the steel had decreased to a large extent on lots of floors. Now they were going up the up the building and replacing fireproofing as needed, or when floors became vacant. But that long-term bond of the fireproofing to the steel is very important. You know, if it works and you spray it and 28 days later it passes a bond test, but it's not there 28 months or 28 years later, it's really a failure. So we did learn something from that. And you know, the NIST report talked about a lot of things, but I'm just dealing with the fire protection systems. The bond strengths of SFRM were not sufficient for high-rise construction. So high-rise construction, much bigger of a target if you were interested in taking down a building. Though the bond strength of fireproofing was the same regardless if you were building a 2-room auto showroom on a ring road or a 70-story high-rise in the middle of a city. And so as a result of the World Trade Center tower failures, there was some review of the bond strengths of fireproofing on the structural steel. Inspection and maintenance of the SFRM was not a priority. Bill did touch about that, and he and the NFCA and others were successful in making this more of a priority. Like, it's not just a case, it is not, and George again touched on it too, I believe that, or sorry, the speaker before, it's not a case of just spraying it and hoping for the best, sort of feel good fireproofing, spray and pray fireproofing. We have to maintain them. And if you look at your NFPA standards for almost any active systems, or even sort of like NFPA 400, which is the Hazardous Materials Code that talks about inspection, testing, and maintenance. Nearly every NFPA code has an ITM section, typically towards the back of it, but it's annual, or every couple of months, or 5 years, every pump has to be retested. And we didn't have that requirement. We still really don't have that requirement for SFRM, but we're moving in the right direction. So now there at least has to be a register of what fireproofing is on site, and you're supposed to at least look at it once a year, just to make sure that the product remains on the steel. You know, if it's not there, it can't work. And there's a fairly famous study by a fire protection professor at the University of Maryland that talks about the failure of unprotected steel. And W10 by 49 column, which is a fairly common one that we test, will see significant reductions in the fire resistance rating if you expose pieces of steel the size of a quarter. So a piece of steel that's unprotected on a W10 by 49, you can expect to see a reduction in the fire resistance rating of about 15% of 1 hour. So if it's fallen off or it's been knocked off by other trades, you will see significant reductions in the fire protection. And there's a saying within fire protection, within that a failure everywhere or failure anywhere leads to a failure everywhere really quickly. And that's just the way it is when you see fire tests. As George mentioned, if you get a chance ever to go see a full-scale fire test, it is really illuminating how hot they get, and how quickly things go pear-shaped once they start to go. Like, it's fine, it settles along, and the fire test is great, and then all of a sudden it just gets hot, and once it starts to go, it goes really quickly. The inspection and protocols in the ASTM standards E736 and E605 were not sufficient. They really were. They didn't require enough inspections, so you could do very little inspections and get a pass on the building. The building code has been modified now to increase the inspection frequencies. And as I just talked about, no maintenance or periodic inspections are required. So what did we learn? Restrained construction, less conservative, I mentioned. What's become of this? Nothing really. That is still a thing. There has been no real move away from allowing buildings to be deemed restrained. The building code does require that everything be initially classified as unrestrained, which is appropriately conservative. But we do now see far more buildings becoming or being deemed to be restrained. When I first started, and I'm not nearly as old as Bill, but we never saw restrained construction anywhere outside of New York. Now we see restrained construction everywhere. the methodology hasn't changed. The teaching of the structural engineers in engineering schools hasn't changed, but the big driver is money, right? Restrained construction is cheaper, and it has some significant fans that have been pushing pretty hard on the code cycle, or on the codes, sort of trying to figure out ways that they can manipulate the ASTM and UL standards to get more products or more projects to be deemed restrained. So unfortunately, that hasn't been beneficial. Long span joists cannot be tested. They're still widely used. We still see trusses 60, 70 feet long. We have no way to test them. We've no idea how our products will react when they are exposed to that level of deflection during the fire test. Ambient conditions are fine. There's no real issues. It's when they get hot and they start to sag, what happens? Because we're just not able to test at that level or that length of span, and we can't measure or know how we'll do with that level of deflection. As I mentioned, bond is an issue. We still see products that have poor long-term bond being widely used. Again, it's a money thing. To my mind, certain types of fireproofing products should have been discontinued completely after a series of fairly high-profile fires in the US over the past 30 or 40 years. Bond strengths of SF/M were insufficient, as I mentioned. We had some success there. So what we did is there was a period after the sort of the window of outrage, I think they called it, where we were able to get an increased bond strength requirements for SF/M in high-rise construction. So once you go beyond 75 feet, we do see an increased requirement for bond strengths. And then once you go beyond 430, it jumps again. So bigger buildings do require products that are much more likely to remain in place for a long term, have much greater bond. I'm not sure, because it's not a standard test, if anybody would be able to test that level of impact. But there are products that can withstand a significant blast effect and still provide the fire resistance rating. Just when I touch upon that and I say that there's no bond test, or there's no test for that, to Bill's point, one of the things as a task group chair of the ASTM that drives me insane, and as a sort of fire professional, is the YouTube test standard, right? People putting videos with Bunsen burners and all sorts of other nonsense showing how effective their products are. There are thousands of test standards that can be used properly. We don't want to see a situation where some guy is making intumescent, no disrespect to that guy from Hilti, but is making a fire protection product in their bathtub, and they're running some sort of Bunsen burner test and going to the AHJ or going to the spec writer or going to the architect and saying, our product is acceptable, look at this test. There are plenty of standard tests available that demonstrate compliance to the building code or your specifications. Greater inspections, again, a success. We've had much great, I think we're at a 400% increase in the amount of inspections that are now required. So we do see much more, a greater, I wouldn't say, we see a much better application, I think, of SF/Ms than we probably did, because the chances of getting caught or a poor application being picked up upon are much greater now than they were previously. And then no maintenance or periodic inspection. Again, we've had some success there. Mandatory annual inspections. They must keep an inventory of what they've got. So that's been a good thing. And I think as we go on, we will see that becoming much more appreciated. There'll be a greater understanding of why it needs to be done. So that to my mind has been a big success for us. So off-topic successes, how, like, what these failures, these two big failures have. We saw a big increase in enrollment of fire protection engineers. WPI, University of Maryland, Cal, Oklahoma, they've had big increases in the number of people that have been interested in fire protection. People are much more aware of the role of SF/M than they were previously. You know, everybody became an expert on fire protection sort of for a couple of years there after the World Trade Center. They all had sort of various theories about what happened, but we've seen a much better understanding of it. a realization that simply containing the fire was not sufficient. And, you know, there needs to be, there was a step back from this perception that sprinklers were the be all and end all. Sprinklers are outstanding. If I were building a new home, I would want them in that home. They offer a great level of fire resistance, but they're not infallible. And having a product such as ours that protects the steel, allows the sprinklers to work. You know, it keeps the structure square. It allows the fire stopping products to work. So if the fire gets out of hand and the sprinklers are struggling against it, the steel provides support in many instances for the other fire rated systems. So like you need a 2-hour separation between your fire pump and the rest of the building. That passive resistance is important. It allows the fire stopping products to work. If the steel begins to sag and it pulls the fire stopping off the wall, then it's going to allow the smoke and other byproducts of combustion to move around the building. So we're much more aware of that now. And you know, a sort of a nod to Bill and the NFCA, we have seen a fairly significant increase, a huge increase in the responsibility taken by the fire protection community to doing the right thing. The NFCA as an entity in 2001 was 20 people. It is now probably 10 times bigger, if not bigger than that. And there is a much greater drive towards accountability, towards having people on the fire protection team being qualified individuals, as opposed to just somebody who has been doing it for a long time. There's a series of exams that the NFCA offer, that UL offer, that allow people to become ICC qualified or to be a competent individual to run fireproofing crews, which is important. To my mind, because this is not an AIA presentation, this is probably the biggest failure. I'm not a big fan of this sort of mineral fiber based fireproofing. I think long term it has an issue, and it becomes very friable in the long term. It is a failure of a fire protection system, but can we learn from it? There are plenty of alternatives available. There's always the cementitious products, the likes of Cafco 300, Southwest Type 5, Carboline's product, Monaco. There's various intumescents that can be used too, but I'm not a huge fan of mineral fiber based fireproofing as a rule. So case studies, One Meridian in Philadelphia. Like, would this be considered a failure, right? So big fire, building didn't collapse, stayed upright, stayed square, eventually had to come down. So would we say it's a failure or a success? These are the beams inside the building. So you could say, well, look, the loss of life was small compared to what it could have been. Unfortunately, there were some people who perished. But the building was so badly damaged by the fire that it had to be demolished. So from like a continuity of operations, from an environmental impact, from an insurer's impact, that was a failure. That was a failure of the fire resistant systems. What can we learn from it? We would say that restrained systems or buildings that are thermally restrained do not offer the same level of fire protection. Once it becomes a big enough fire, it's a kind of one and done system that you'll get one fire out of your building because you can't fix this. Then I would look at another one, First Interstate building in Los Angeles, California. Similar type of fire, huge office building, fire burned for 4 hours and 43 minutes, I think it was. But the fireproofing, the thickness of the fireproofing, because it's an unrestrained system, was significantly greater, maybe 50% greater. It was a definite success. There was no loss of life. The building remained standing. You can imagine something like this coming down in a city like Los Angeles, how horrific that would have been. It remained standing. The businesses were able to reopen in the building 4 months later. No environmental damage, as opposed to like the cost and the environmental impact of repairing or replacing such a building. And if you look at the pictures here, like these are the same sort of steel beams within that fire zone. You'll notice that they didn't sag, that they remained pretty square. The fireproofing had to come off, but I mean, as you can see, the place was a complete mess. But they were able to just reapply product to it. And one of the, I think the kudos that I would give to my own company and to to my competitors, Isolotech and Carboline and Hilti and stuff, is these big companies tend to have extremely good quality control programs. And it's, you know, you would expect this level of result. This is what we're hoping to achieve. And so this, as a failure, sure, there was a fire. Sprinkler system didn't work, was decommissioned. But you would say that this was a success. So we did have a failure, but we did gain something from it. We learned that unrestrained buildings do tend to survive better in fires. So what do we as engineers, architects, specifiers learn from failure? You know, how we would define a failure or a success with your fire protection system. So it's complete evacuation of the building, effective compartmentalization. We did have that compartmentalization schematic from the building code, the UBC maybe, but are these how we would define success? Loss of life is clearly the worst case. Clearly nobody wants that. And if we can prevent that, then we're in good shape. But you know, the fire problem in North America is not really related to what we do, and you as architects and whatnot. It's not really our thing, because the number of people who sort of die in bigger fires has been dramatically reduced since the early 1970s. The problem still remains in houses. The number of fatalities in houses remains worryingly high and is pretty constant. And that's where the sort of the fire problem lies. That's where the real focus should be, or should be within the fire protection community. Protection of the asset. You think about the cost of replacing something like the World Trade Center, billions of dollars that would go in, the enormous impact that's got. Is that the criteria for success or failure? Business continuity, again, businesses go down for months at a time. Is that a loss? Yeah, that would be a loss. Environmental damage, the cost of replacing all that concrete and steel is enormous. And is there such a thing as a good failure? Absolutely. So within the fire protection, so we do a lot of fire testing. We do a lot of fire testing, not just for ourselves, but we do quite a lot of it as part of UL sort of industry standard groups. And we learned a lot from those failures. Several years ago, we were part of a team that paid for 8 full-scale fire tests, and it did lead to a significant increase in our understanding of an issue with respect to how assemblies are loaded during the test. This sort of has made the building safer, but we did, burn through $1 million worth of money failing systems just to sort of get a better understanding of it. And as we talked about, those buildings that where they had those large scale fires, they did make the rest of the buildings or buildings built subsequently much safer. And the failure of products in the field lead to increased understanding of what products are acceptable. Yes, I would say that's true. So when we go and we do bond tests, or when we do deflection testing or air erosion testing of products in the field, and we learn that certain products will fail under certain conditions, that should be a key for you as specifiers to say, well, I'm unhappy about the bond strength or the air erosion properties, or any other of the 12 or so ASTM standards that we use for SFRMs, to choose better products. That's me. So that's my that is my presentation, George. I hope it was what you were looking for.
Thanks, John. And that was some really good stuff there. Thanks for your time. Hang around if you would, and we'll have some questions at the end.
Yeah, of course.
And now let's ask our next speaker up to the podium, please.
Coming up to the podium now is Nick Lindenmeyer, who is from Hilti. We know Hilti at this chapter for many, many years. I know Steve and I, and probably many of you, were introduced to penetration fire stopping by Hilti. They were a leader in teaching us all about what it was and why it was important.
All Alrighty, thank you for having me. It's supposed to be us. John Meadows was supposed to be with me, but he had some stuff come up, so just kidding me. So hopefully I'm enough for you guys. But my name is Lindenmeyer. I am the fire protection specialist in St. Louis with Hilti. So I've been with Hilti about 5.5 years now. Started in the field as an electrical account manager, so called on the Sachs Electrics, Guarantees, Bell Electrics of the world. Learned a lot about construction. I don't have a construction background before that, so learned a lot about construction these last 5 years, and learned a lot about Firestopping in my role as well. Something that really piqued my interest, something that I really grasped hold of right away. The fact that if you do it the right way, it does protect the buildings, right? It makes the building safer, allows people to get out of the building safely. So that really hit home for me. So I'm gonna go through the presentation. I think I got 20-30 minutes here to talk to you, and then we'll do some questions at the end. All right, so here's kind of my agenda here. I want to give you a little brief background on Hilti. Won't take up too much time. It's a consequence of fire, go through some fire stop failures, and just really incidents in general. Some installation examples, and some fire stop maintenance to wrap it up. So Hilti is a global company. We're on 6 continents, over in 120 countries. We have 30,000 employees worldwide. Cool thing about Hilti is we do everything internally. So we do all of our sales and marketing direct to the field. We have our own testing facility down in Plano. And we do everything internally, which is awesome because we can do these types of events with you guys. North America, we have over 3,000 employees, 1,500 account managers, 200 reps like myself that are fire protection specialists or field engineers. That go out in the field, basically do job site walkthroughs with customers, make sure things are getting installed the right way. We offer job site trainings, again, just making sure the customers know exactly what they're installing and how to install it. I'd like to open it up with a question. How often do you guys think a fire department responds to a fire in the U.S.?
Every 5 minutes.
5 minutes, okay. Anyone else? So it's actually every 23 seconds, fire department responds to a fire in the U.S. And I get all sorts of guesses, 5 minutes, 2 minutes, 10 seconds. So it's actually every 23 seconds. So every year, it's about $20 billion plus in direct property loss. And the most important, and kind of the reason why I do it every day, and the reason why we want to make sure it's done right, it's over 3,500 lives lost each year due to fire. So anything we can do as the contractor, architects, the installers, anything that we can do to mitigate that risk, the better. So we're going to go through some examples of some fires. George talked about this when we took the phone call originally. So the MGM Grand is kind of where it all started from a fire stop perspective. Back in 1980, so 84 people died in this one. There's nearly 700 injured. Over $200 million worth of claims. Again, when we talk about the 3-prong approach to fire protection with the sprinklers, the alarms, and the passive fire protection with the fire stop, things have to go right for the sprinklers and the alarms to work right. There has to be a power source. You guys know if you're in a building and a fire alarm goes off, what's typically the first reaction? Look around to see if it's a drill, right? A lot of times it's too late at that point. Things have to go right. There has to be, like I said, a power source. There has to be water in the sprinkler system. That's where this fire stop kind of got started, and we realized that this was an important deal. So when we talk about from a compartmentation standpoint, like George noted that before, again, the fire started on the 2nd floor. Most of the deaths occurred on those upper floors. So the idea behind Firestop, if it was done correctly, is containing it to that 2nd floor or a portion of the building to allow people to get out and exit the building safely. We touched upon a couple of these already, so I won't spend too much time. But again, on this one, sprinkler system was drained, and there was some issues with the actual fire stopping within the building from floor to floor. Some of the poke-throughs and vertical penetrations were not done correctly, which allowed the fire to kind of spread up and down the building. Same thing, we touched on this before as well, destroyed the building. 3 firefighters died in this one, and that's kind of an interesting point too. I do these types of presentations with, I do with the inspection community, do with fire marshals, do with subcontractors. One of the first ones that I did it with was a fire marshal, and they said absolutely the idea is to get everyone out of the building safely. It's also allowed the firefighters come in, put out the fire, and also exit themselves, right? So when they're going into a building and we're talking about fire rated assemblies, you know, the 1 through 4 hour ratings, they're going to be also taking that into consideration. If the fire stopping is done correctly and it's a 2-hour assembly, fire's been burning for an hour, in theory, they need another hour to get in and out of the building before that fire spreads. So those were a little dated fires. This one was 2017, so 5 years ago, right? So this was very similar in the death count as well as the MGM Grand. 80 people died in this fire. Again, a 4th floor fire. Most of the deaths occurred on the upper floors, as you can see here. And when we're talking about the maintenance of fire stopping, I think this one's a crucial one to note. So the quote there that you see is that inquests have found that botched renovations had removed fire stopping material between flats and communal corridors, allowing the blaze to spread. So here's kind of a 6-picture shot, or a 9-picture shot of it rather. First photo was taken at 1:30. Last one was taken at 5:15. So again, the outside of the building just really allowed a chimney effect to spread all the way up the entirety of the building. And you can see here, just really engulfs the entire building. Every single side of the building was charred. So when we say these fires are a thing of the past, this one was, again, last year. Fortunately, there was 0 deaths in this one. This was a fire in Milan. I don't know if you guys heard about this one. Started on the 15th floor. The outside of the building was done with flammable material. 20 to 30 people were hospitalized for smoke inhalation. Thank God there was 0 deaths in this one, but after seeing this fire, again, it's an issue that needs to be addressed. And I thought the quote on this one was interesting. So Mayor of Milan said the tower was built just over 10 years ago. It's unacceptable that such a modern building should have proved totally vulnerable. So it's still very relevant, something that I'm passionate about doing it the right way and showing the contractors how to do it the right way as well and take their time and actually care about doing it. So that's what I want to discuss today. So I have a couple more examples and then we'll go to the rest of the presentation.
Is that one of those fires that the fire actually came down?
Yeah, so it started on...
Wasn't it spandrels or something like that?
Yeah, so it started on the 15th floor and you can tell on the outside of the building, it went up and down there, so yeah. So this was actually sent to me by one of my coworkers in another region. I hadn't heard about it, and they sent me this and did some research on it. And there's 50 people approximately in the building at the time, 0 deaths. I have no idea how. Thank God though that they could get out of the building, but yeah, I mean you can see it completely engulfed the side of the building. So the last one I want to talk about, and then we'll go to the rest of the presentation, was the Station nightclub fire, 2003. Some of you may remember this. So this one, there was 462 people in the club, which is actually 50 more than was supposed to be in there with the venue capacity. So 100 people died in this one, over 200 hospitalized, and ultimately it was pyrotechnics that went off, basically caught fire to flammable acoustic foam that was in the ceiling and the walls. Let's see if this video will play. We'll see here. That's all right. If you could have seen the video, it's one of the scariest videos I think I've seen. So it shows the fire, it shows the concert happening inside the building. Pyrotechnics go off, the sparks are going, and then it starts a timer, and it's a timer that sits at the bottom of the screen. If you have a chance, look it up. Just look up Station Fire 2003. So it starts the timer, right? And it gets to a minute and a half. You can't see in the building because the smoke has just completely engulfed the entire building. And because the venue capacity was over what it was supposed to be, again, I wasn't going to show the whole video because it does get kind of graphic and really, it just gives me goosebumps watching it every time. But people are literally trying to get out of the building and physically can't get past one another because it's such a tight corridor, and just because the fire spread so quickly. So it's a scary video. I always show this to my contractors because it really hits home that this can happen anywhere, and we got to do our part as the manufacturer, the contractor, and the architect to make sure that we're fire stopping the building correctly. So we asked, why do these keep happening? I think it's a variety of reasons. It's not just one thing. Lack of fire stop knowledge on products and systems. So the guys before me mentioned everything's tested in accordance to a system. So I usually bring a tube of fire caulk with me to my presentations and to my subcontractors, and I'll throw it to one of them and say, what's the hourly rating on this fire caulk? Get a variety of answers, right? 1 hour, 2 hour, 3 hour, 4 hour. The answer is 0, right? And they're shocked when I tell them that. We don't have a magical fire caulk that you can put it on anything and it's going to put the fire out or stop the fire, right? All of our product is tested in accordance to a system, and it's very specifically tested. The amount of depth, the type of product, what can go through the penetrance, if it's a metallic versus non-metallic pipe. So a lot of times when I'm in the field with these guys, and I'll go up to them randomly and say, what system are you using? I don't know, just put fire caulk on it. It's kind of scary, right? That this is happening. So lack of knowledge, I think that's a major one. So that's part of my job, is to do these type of presentations, walk through a fire stop system with them, a UL system with them, show them exactly how to fire stop it the correct way. And again, to that point, not following it to a T, right? So if it says a 4-inch pipe and they're installing a 5-inch PVC, they say, oh, it's close enough, right? Again, they're all tested very specifically to the metrics that are on the system. So rushed work and inexperienced work. That's the other thing when we go on job sites, is who's typically the one doing the fire stopping? It's the apprentice. Guys in the field don't want to do it, right? So they give it to the apprentice, say, hey, have fun. It's not fun to do, but it is very important, right? It's a messy job, but I see that all the time. We ask them who's going to be doing the fire stopping so that we can go educate them. They're like, oh, it's the apprentice, right? So rushed work, inexperienced workers, a big deal too. Cutting corners save money and time. Like anything, you like to think it doesn't happen, but it does all the time here. You can see it on the picture there. It just kind of globbed in there. It was rushed. They probably didn't use the right amount of product. Anything people can do, and I'll show you on a couple slides here to cut corners to save money and save time. You don't want to think it's getting done, but it definitely is, and I'll show you some of the pictures I've been sent. So, and then port rework, again, when we talk about the Grenfell Tower, the fire stop that was taken out and not replaced, that's a big deal, right? That's something that us as architects, as the manufacturers, we can educate the building owners on how to do that, how often to do that, and what to look for. So here's an example of where a customer mixed product. So again, these are chemical products. They're not tested with other products. We don't test with our competitors. We don't test with drywall mud on our product. It's kind of crazy. I had a contractor. I showed him this video. He said that's what we used to do. That was just best practices. You get a tube of fire caulk. You get your drywall mud, mix it together, throw it in the opening, right? So that just doesn't fly. We don't know how it's going to react. Again, it's a chemical. We don't know how they're going to react with each other. This one, believe it or not, was actually good in theory, right? So it's a 4-inch pipe, a 4-inch PVC, which we don't have any systems that are just plain fire caulk for 4-inch PVC. You actually do have to use a fire collar. But I can guarantee you that it does not say shove the tabs up into the conduit, right? That's not how the system reads. So those are supposed to be fastened in. So if you can imagine a fire, PVC melts away just about 400 degrees. Once a fire happens, that's going to fall out. That device is going to fall out. That's just going to be a passage for smoke and toxic gas to get through, right? So this one, I actually took this picture myself. Not going to disclose where this was, but this was a picture that a customer came up to me. They had me walk a job site with them. They said, hey, can you get me a case of fire caulk? I need to fire caulk that. I said, nope, not going to do that.
You just set the whole case in place.
Yeah, exactly. Hope it works, right? Yeah, so this one, a couple things going on, right? It's a 4-inch pipe, so automatically rules out fire caulk, FS1. It's going at an angle. It has an elbow in the opening. It has 2 hubs in the opening. So we had to do an engineering judgment on this one, but it really just amazed me, and it really shed some light that contractors don't always know what they're doing, right? And that's part of my job, is to educate them on best practices and what not to do. They don't know what they don't know. So anyone have a guess what that is? It is. Yeah. So I get a variety of answers on this one as well. A lot of times people say putty pads. I wish that was the case. It's not the right application, but at least it would have been somewhat fire stop, right? Red rubber gloves that were shoved into the opening. Again, these aren't pictures we make up. These are actual pictures that we've either taken or that inspectors send us. And it's really just amazing. People trying to cut corners, not doing it the right way. Obviously, you guys know if fire occurs, that's just going to burn up right away along with those cables. And that's just going to be a chimney of smoking gas through there. Very similar situation, right? Calls for a certain amount of depth of fire caulk. Fire caulk's expensive. I can tell you it's even more expensive if you have to do it over again. So they tried to stuff paper towels in the opening to simulate that they got enough depth of fire caulk in there. They're probably calling for mineral underneath, and obviously paper towels are not very fire resistant. Neither is toilet paper, right? Yeah, it is absolutely astonishing some of the stuff we see.
That is awesome.
And during the COVID times when toilet paper was scarce, maybe they were saving it. I don't know, but not a good thing to do, right? It's very real. It still happens. You know, I gave the examples of all the fires. It still happens though, right? There's still going to be situations where people are trying to save time, save money, and it's not the right way to do it. It's a life safety issue. People's lives are at stake when they're in a building, especially if you think about a hospital, a senior living home, an apartment complex, a hotel, anywhere where you're not familiar with the layout. One of the guys mentioned with the residential, you know your home layout. People still die every day in their own home because they can't get out because of that smoke. Now imagine a place, a hospital or hotel where people are either moving slower or you don't know the layout. That just makes it even more challenging to get out of the building. So that's why we have to have this fire stop in place. So maintenance, how often? These guys touched on it a little bit already. So it is annually. So here's a little snippet. So I'll start kind of where it gets into. So such construction shall be visually inspected by the owner annually and properly repaired, restored, and replaced where damaged, altered, breached, or penetrated. So they call for records of the inspection, which we'll go over. And then one of the gentlemen mentioned it before, where it's concealed, does not require to be visually inspected unless you can get to it. So if you can lift a panel or move a panel across or a ceiling tile to get to that, it needs to be inspected as well. Anything we can do as the building owners to inspect it the right way and periodically, annually, that's what we need to do. So what's it look like? Typically when I'm doing fire stop presentations, I harp on the labels, right? So labels are great for a couple of reasons. One, for the inspection on the front end, right? Makes the inspection for whatever city inspector is doing it. They have the system, they have the product, who installed it, when it was installed, all those good details. And if you look at this one too, right by the application, it's perfectly tooled down. Same thing with this one, looks really nice. These are what these labels look like. These are crucial in maintenance. This is how the building owner knows what's to be inspected, what product was used. So I tell the customers there's 4 main takeaways on these labels that you need to fill out. At the bare minimum, everything else you're welcome to fill out too, but product is one of the first ones. Obviously important if something gets damaged or if a cable gets pulled out and fire stop follows out, we want to make sure if it's a putty stick that was in place, if it was a pipe collar, if it was FS1, if it was a silicone, we want to know what product it was. The most important one on here is the system, right? So if the fire stop gets damaged, we want to be able to go into Hilti's website and say, okay, this was WL1054. This is a metal pipe through a jump wall. How do we fire stop this? How do we make sure that it's the correct fire stop that's done right now on it? So those are the 2 most important. Customer names, so the contractor who did it, if they do have any questions, you can reach out to them and get information from them. And the date of install. Obviously, why that's important, we want to make sure that we're maintaining it once a year, annually. And you can also put on there when it was reevaluated or re-inspected. And then once those run out of spaces, you can throw another label on top of it and continue on. So these are crucial. They're supposed to be required on every job. Whether that gets done or not, it really just depends on the jurisdiction. And a lot of times the GC pushing it from their end. So that's something when I do our demo days and I do our presentations with our GCs, That's something that I push every single time, is for them to really push that on their end, for the contractors to do that, because it just makes the whole process a lot easier. Not only on the front end with the inspector, but on the back end with the maintenance, which is a crucial point of the fire stopping as well. So the last two topics I wanted to cover are fire stop mock-ups, and then the subcontractor interaction with the manufacturer and what that looks like from our end. So we do these mock-ups as often as we can. We actually did one with Apili and those guys in the office there. So we mocked up a wall. We ran a bunch of pipe through it, cables through it, and then we actually had their guys fire stop it. And fire stop it, tool it down, put the labels right next to it. It has a bunch of advantages from an office perspective and also from a job site perspective. So with the office, when they're onboarding new employees, they can obviously come in, see how the systems are laid out. If they have any questions, they can use that as a point of reference. Also, if they get into a situation where they're on a job site and they see a metallic pipe or see a similar situation, they can call me and say, Nick, we know it's something similar to WL 10054. This is the alteration. What do we need to do to fire stop this the correct way? They have a point of reference if you have a mock-up board. We're also seeing a lot more on the job sites as well. So with the job sites, again, with planning and executing the fire stop, it makes it a lot easier for all of the contractors. We've seen it on a couple projects recently that they've mocked up walls beforehand, had me come in, looked at it, make sure it's done the right way, put the system labels right next to it so they could instill that best practice. So it makes the inspection process easier, because the idea or the goal behind it, right, is that there's less error when they're doing it for the real thing and on the job. But I really like these mock-up boards. This is an example of one down in our testing facility. So basically, we'll mock up a wall and have UL come in and look at it and basically walk through the burn with us. And I've seen one of our burns. It is very cool to see. It sucks when you have to wait there for a 3-hour test and then just watch it, but it is cool. So these mock-ups are great. Last thing I wanted to talk about is just Hilti's interaction with subcontractors. So we try to get involved way ahead of the process, and kind of what we pitch to our contractors and our customers that we're helping with is we're going to be there before the project starts, during the project, and then after if they have any questions, or if we need to handle any questions from the inspectors, right? So we do the project submittals where we build out a system book for the customer that they can in turn turn to the GC, who turns it into the inspector. We do job site walkthroughs, like I said before, where we'll come out and actually look at the penetrations, let them know how to fire stop it correctly. We're getting involved on the BIM side and the pre-construction coordination with clash detection. We have our own program and our own team that we literally just came out with last year. So we're starting to see that more and more often on job sites, is just getting all this done beforehand. And we have, like I said, our program basically loads all the penetrations in from the drawings, gives us any spots where we're going to have clash detections that we're going to know we need engineering judgments beforehand, so we can jump way ahead of that, and it's not at the end of the project where they need it like this, right? It's getting it all done beforehand. And then finally, doing the installer trainings. So we do these in the office, do these on the job sites. Again, it's just a best practice where I come in, talk with the contractors about how they fire stop currently, who knows anything about fire stops, sharing best practices that I've heard from inspectors, and really showing them how to read a system and just best practices with fire stops. So that's all I have from my end. I really appreciate your time. I'll be here for questions as well. And then that's my information. I'm going to leave some cards for you guys as well. If anyone does have any questions or wants to get a hold of me, you'll have some cards as well. So.
Thank you very much, Nick, and thanks all of you. Can you get John and Bill back up on the screen?
Yes.
Okay, so while Hank is doing that, I will start to take questions from the group, and I'm going to walk around and stick a microphone in your face. But don't be intimidated. I'm sure since we had so much to cover and I limited them all to 20 to 30 minutes, I thought they did a great job in compressing a lot of valuable information into the short time. So, any questions for anybody? Any questions?
Oh, come on, you guys. I promised that this group would be full of questions. Yes.
Bill McHugh here. You mind if I share my screen for a second?
Sure.
All right, let me go hit that screen real quick. Give me a second. You know, both John Dalton and also our friend from
Sorry, that was
Hilti.
my mistake.
Can you hear me okay?
Yeah, my mistake. I apologize.
Yeah, that's all right. You know, Nick and John both really hammered some of the existing buildings issues, fireproofing being on buildings. And, you know, John Dalton hit on the fact that there was quite an evolution after the World Trade Center attacks and the collapse of World Trade Center 1 and 2, and then also 7. 7 was the one that no jet plane hit it. The debris flying from 1 and 2 flew into it, started the open plan office on fire. The fire went around circular fashion, jumped from one floor to the next, and kept on going. Quite a success in how long it stood. The reason why I'm sharing my screen is to give those specifiers and, you know, maybe architects who have clients a little bit of a story about maintaining fire resistance. Two things. John Dalton hit it on the head that our industry has not been very respected in a lot of ways, from the building owners and sometimes from the contractors that are installing the products. He mentioned that some training is required, some education is required. I can tell you that the fire stop industry has been trying to educate the trades for 40 years. And what did Nick show you? A bunch of pictures that were an absolute mess. I really think something needs to change about who is allowed to install these products. It's hard for the manufacturer to restrict where they sell to, but you can control some of that with your specifications using the FMUL programs, the NFCA programs. The big thing that you need to do to be of value for your company and for your client is to let them know that not only does the International Fire Code have some language about maintaining fire resistance, but so does NFPA 1, so does NFPA 101. The reason why I put up the language that you see in front of you is because you know, Nick from Hilti read off exactly the same language that's in yellow. Maintain, properly repair, restore, replace where damaged, altered, breached, and penetrated. Removed, or NFPA 1 adds improperly installed. If I were asked to be the expert witness for a plaintiff that lost life or property, their family did, the first place I'm going to go after that building owner is these fire codes. Because if you ask a group of building owners, do you maintain your sprinklers? Yes. Do you maintain your alarms? Yes. How about your passive fire protection? And you'll get a blank stare. But if they put in their budget every year to do something to maintain their resistance, you know, take a look at the beams and columns where they're exposed. The intumescent fire resistant materials might have gotten bumped that's on steel. Same thing with spray fire resistant materials. Someone that has expertise needs to be able to repair that. And someone with expertise needs to be able to do that annual visual inspection. NFPA 101 even goes as far as to say that. Let's see if I can, here we go. There's NFPA 1, look at this. A written report prepared by the person responsible for construct shall be submitted to the AHJ, and then the person responsible has got to have technical knowledge. Think about yourself maybe as an expert witness someday where there's been an issue with fire resistance. I mean, the fire codes are just screaming to the building owner, you better take care of this stuff. Sprinklers aren't perfect, alarms aren't perfect, passive fire resistance isn't perfect. But all three of them have requirements to maintain their protection. I'm not going to go any further, but just know, look at all these slides. Look at them all in the fire code. Advise your clients that they need to take care of this stuff. And, you know, frankly, we'll be able to protect people better in buildings. Well done to our co-presenters. Each one of you guys did a great job. Thank you for doing that and representing our industry well. Other questions?
Thank you, Bill, and thank you for all you've done over your career to inform a lot of us on stuff that we didn't know and should have known. Fred has got a question here.
Thank you, George. My question has to do with penetration fire stopping. Invariably, we specify that to be single source stop project. And on almost all projects, invariably there is some point where the contractor, general contractor or CM, in conjunction with the main trades, asks that not be done, that it be fragmented between different trades. So mechanical, plumbing, electrical, communications, security wire, etc. is all fragmented. Why is that such an obstacle? People always talk about that being a cost. Why would that be?
Yeah, let me address that real quickly. It's a great question. And here's why the cost question comes up all the time. The slides that our Hilti representative put up show you that some people think the fire stop industry is a joke. The difference in cost for doing it right versus the tube of fire caulk is about 10 to 25 times different.
Unrestrained structure.
It's crazy. So that's why they're saying cost, because the trades have no idea what they're doing. They don't know how to cost it out. So they're throwing at you that it's cost. It's not cost. If that trade contractor knew what it really cost, their price would be more expensive than the specialist contractor because they have no idea what they're doing, and the specialist contractor has the efficiencies. Inspection does help. The special inspection agencies, if they're good and they crack down and they don't coach the fire stop installing contractor that's from the trades that has no idea what they're doing, if they don't coach them, even if they do coach them, it's still going to cost them more money than they think it's going to cost them. The FM and UL contractor programs in your specs is a good way to do that. Just have the trade contractor get themselves FM and UL, or either one. It's public, open, they can all do it. It's not like it's a barrier to entry. The big thing is they're screwing it up big time, and they're doing it through price. They're not doing it right, and the price shows it. 20 times cheaper, if not more.
Thanks, Bill. So Bruce had a question from our Zoom chat, and I see that John has already answered it, but basically he's asking, what's the difference between restrained and unrestrained?
Yeah, so I see a wry smile on Bill McHugh's face there because he knows this is a topic dear to my heart. When you run a fire test at UL, the overriding criteria is that the beam does not collapse into the furnace. And if the UL test furnace is 4 enormous pieces of steel that are embedded in concrete, and they provide a huge amount of support to the beam during the fire test. So when they put the beam into the frame, they actually physically restrain it against the sides of the furnace, and that stiffness provided by the furnace helps the beam tremendously. You can measure the stiffness of the frame. It's 850,000 kip inches, and what the building code says is that if your frame of your building provides less of a support than 850,000 kip inches, you have to deem your building to be thermally unrestrained. That is the default position in the code, is to be unrestrained. It provides certainly a higher level of fire protection to your furnace. When it's unrestrained, the beam is just free to rotate, and all of the protection and support for the assembly comes from the beam itself. You're relying solely upon the fire protection applied to it. When you've got a restrained assembly in the furnace, the frame that's not part of the fire test provides an enormous amount of support, and it helps it out a lot during the test, so you need less fireproofing.
Thank you, John. And Steve had a question.
Actually, you just another question popped into my mind, John. Then I got one for you, Bill. When it comes to restrained versus unrestrained, there's an option in our specifications where we can specify fireproofing for unrestrained or restrained construction. Should we specify unrestrained construction?
I think by code you have to. The way I don't have it right in front of me, Bill, but what the building code says is that that unrestrained construction is the default position, and if you can prove by calculation or evidence that the building has more than 850,000 kip inches of stiffness, then you can go with restrained. I've only seen it once where somebody actually provided the evidence and said, here, yeah, like I've done the calculations, and and it's an enormously complicated calculation. I think very few engineers would be able to undertake it. So as I mentioned, I think Bill might be able to pull it up there pretty quickly. But
Yeah, I'm looking for it now, John. I'm trying to think of where it is. Oh, there it is. 703.213 in the 21 code. Fire resistance rated assemblies tested under E119 UL 263 shall not be considered to be restrained unless evidence satisfactory to the building officials furnished by the registered design professional showing that the construction qualifies for restrained classification in accordance with E119 UL 263. Then restrained is identified in the documents. 703.213.
Bill, my other question for you is, I was quite happy when my son decided to go into electrical, and he's an apprentice right now. He's only 20 years old. I was a bit disappointed when he came home from work one day and proudly told me that he was firefighting all day. I asked him who trained him, and he said, they handed me a tube of caulk and said, fill those holes.
Yeah.
Is there any reaction to, why aren't the building officials catching this when they do their walkthroughs? Because I can guarantee I've seen them paint at home. I know the caulk job was not good. They should have seen something, one of Nick's photos.
Yeah. That's a great question. And, it's one of the problems in the industry that, I can tell you that the code officials from their perspective are not supposed to be the quality assurance agent for the general contractor. And with all of the elements that they're supposed to look at, they just don't have the time. That's why Chapter 17 in the International Building Code now says that special inspection for fire stopping has to take place. And that's why I said I hope that the special inspection agency knew the heck what they were looking at when they inspected that fire stopping. If you think about it, if the inspection agency, and one of the falsities of special inspection is, if the inspection agency is good, then all is good. If the special inspection agency has no idea what they're looking at and just passes it, then we got a big problem. But here's what it says in Chapter 17 of the Building Code in 1705-18. And believe it or not, it's right after the SFRM, IFRM sections is where you'll find the fire stop inspection. So a special inspection agency should have gone through and destructively tested or visually inspected. Destroy 2% of each type of penetration, no less than 1 per 10,000 square foot of floor area. And what they do is they do it by type, in other words, by system, by installation contractor. So the electrician, the plumber, everybody else on the project should have gotten 2% of their holes cut open. And if that inspection agency knew what they were doing, they would cut it and go, okay, well, looks like your thickness is off a little bit. And then secondly, you've got a sleeve sticking up above the floor about 6 inches. The system only allows it for 2 inches to be above the floor. We have to reject this one. Doesn't necessarily mean that they have to go tear it all out. It means they have to find another system that allows them to use that fire stop sealant in that particular application. This fire stop industry and all of the fire resistance industries are a construction discipline all of their own. We've been working like crazy through the Fire Stop Contractors International Association to drive it so that specialty people working for installation contractors that get it wind up doing this work. I can tell you that in the last 23 years, it's gone from a market share of maybe 2% of the projects using a specialist contractor to, depending on the project type, anywhere from 35 to 75% of the time, you'll find a specialist fire stop contractor. The super high-rise buildings, the hospitals, you'll find that more and more. Not all the time, but I can tell you it's getting better, and I hope it keeps on improving. And I hope that the electrician figures out somehow through inspection that they're going to wind up costing themselves tons of money to do it that way.
Okay, I'm back here with Nick from Hilti, and we'll ask him what he and other manufacturers do to help their contractors train their installers like Steve's son so that they learn how to properly install the product.
Yeah, so we spend hour and a half, 2 hours with the customer on site usually, just going over best practices, how to read a system. That's a lot of what the problems stem from is they hand them a tube of caulk and say, have fun, right? They're not going off a particular system until they get called on it. And the inspector says, what system did you use? I don't know, I just threw some fire caulk in there, right? So reading the system is crucial. We'll go through some examples like I showed you guys on fire failures, what happened during those. We'll go through a video showing the testing, how that's done, how quickly that the PVC that they're running melts away, and if they're fire caulking, it potentially does absolutely nothing, depending on what size pipe it is. So we'll spin that with them. I always give them the option of, we work with a couple of Firestop contractors here in the city. If they ever want to get in contact, I provide contact information for them, for Firestop Technologies, for Firestoppers, Rebel. They do great work as well. We spend a ton of time with them trying to just give them the tools to do it the right way, how to clean the penetration before you put it on so that the fire caulk actually sticks to the drywall, how to tool it down properly. We really run through step by step and do our best ability, to our best ability to try to educate them on actually how to do it the right way instead of doing it the quickest way.
I think it's great that the manufacturers spend a lot of time educating as much as they can. They have limitations too in all they do. Think about any construction discipline. The electrician does a 4 to 5 year apprenticeship to become an electrician. The plumber does a 4 to 5 year apprenticeship. Why are we using an hour and a half of education and saying that's enough? I think it's great that Hilti invests that kind of money and time, as well as STI, 3M, and the rest of them. But really, we've got to start looking at this as a specific construction discipline. The FCIA level 1 and 2, believe it or not, it's 30 hours worth of education and exams. And there's other education programs for workers, through the FCIA, obviously, and then the management system of those companies does it. But somehow we've got to, it's not really Hilti's responsibility or any of the other manufacturers to train every single trade worker there is in the country. They can't do it. They do their best and they're great people, but we got to find a way to fix this industry so that the specialists that really understand it are getting it right. Those pictures that Nick showed you are a disaster and really don't need to happen anymore. This industry is evolving. We're trying to do the best we can as an industry, both Hilti and the manufacturers and us too. But it's really got to change. We really appreciate your help in making the specifications as strong as you make them, with the FM and UL programs in them, with all the requirements for special inspection. Some of the responsibilities on us, but certainly something's got to change to get rid of the pictures that you saw.
Okay, it looks like we're wrapping up here. Any last minute questions from anyone in the audience? Or any last minute questions from our chat for Nick from Hilti or our friends in Boston or Chicago?
Thank you, George. Really appreciate the opportunity to be with you. As mentioned, CSI's got a special place in my heart. I've volunteered like you guys have at whether a program chair or president of the chapter. And you know how it goes as president of the chapter, you always have a presentation in your pocket just in case somebody doesn't show up. So really appreciate the work that you put in to make the Greater St. Louis chapter as strong as it is.
No, I just wanted to echo Bill's comment and tell you how much I appreciated the opportunity. Thank you.
Okay. Well, like I said, thank you very much. A lot of knowledge here, a lot of information passed on, and I appreciate it. Glad everybody could make it tonight. Thanks, everyone.